Hello and welcome to this new video of series. In this video we'll see the x-axis and x gantry that will be installed here later on a 3D printer frame. I have two options here. For x-axis, one is these are the 10 mm SS steel rods, and these are the carbon fiber tubes. These are not rods, as you can see. These are the simple tubes having 10 mm outer diameter and 1 mm thick. So these are the two options presently I have. We'll see for which we can go. We will see which is better option for us. And this is 3D printed plastic parts for X gantry. So we'll see how it works. And these are the carbon bushings for x-axis. I am not using the bearings. We'll go for these bushings. So all the parts descriptions are in the link below. So main motto of this X gantry is to keep it as lighter as possible, because X gantry and X-axis of your 3D printer is going to move very fastly. So we'll keep as lighter as possible. These are the steel rods, 10 mm steel rods, and you can see this the weight is very higher than these lightweight carbon tubes. So if you compare the weights, this is better option for 3D printer as compared to this. But if you talk about strength, the steel rods are better. So later on, if you are thinking to convert your 3D printer or use it as a drill machine or CNC machine or laser cutting, so you definitely will be required the steel rods and not the carbon fiber tubes, because if you apply the force, these tubes will get bent little bit. In that case, you will have to use these steel rods to get the more rigidity. In 3D printer, there will not be much forces included. These are the better option. So we will see the dimension of this. So I have cut to the length of required dimension, and this is our X gantry, and these are the guide rails for the bushings and X-axis. So these are the two attachment. So this is going to fix like this, and this will fix like this. We will be using the two rails for X-axis. That's why there are two attachments are given over here to keep it as straight as possible, because little bent won't be accepted and your 3D part will get distorted. Instead of using linear bearing, I am using these copper bushings, because if we use the bearings on these steel rods, and as you know, the X-axis is moving very fast, so that's why there may be chances that the ball may comes out of the bearing. So wear and tear in that case will be higher as compared to this bushing. These bushings won't require any lubrication. These are the self lubricated bushings, and you can see how these move. These are there is no any sticking of these bearings along these rods. You can see how smoothly this is working. And actually these are not the copper bushing. These are the made up of steel only. The outer color is like a copper, and you can see there is a written over here 10 and 20, 10-20. And 10 means 10 is internal diameter and 20 is length of these bushings. So instead of using one bushing, we will be using the two bushings to keep it as straight as possible. If you use one bushing, there may be chances that deviation. So that's why to keep it as a straight, we are using the two bushing, and these two bushings will go inside this, and two bushings will go inside it. These bushings comes in the pack of 10. I have given the link for this. These two bushings will go inside this, one from either side, and these two bushings will go inside this. And later on, this will attach to this one like this, and these rods will go inside to this. So coming to the dimensional of these rods, which is very important in this case, I had ordered the 10 dia of steel, and if you can see that the bushings go perfectly inside this, so there won't be any sticking. So this means the diameter is a 10 perfect. There is no problem using these rods. And coming to the carbon fiber tubes, so you can see that the diameter is little more in carbon fiber. It is not easily going inside, so we will have to reduce the dia of these carbon fiber tubes. So I have this sandpaper with me, so using this I will reduce the diameter little bit. And this is our X gantry, which is moving along the X axis, to which the at the back side the belt will get attached, and at the front two X axis will be moving, and later on the extruder will be get attached to this only. So we'll keep it as lighter as possible to get the better performance. So first we will reduce this diameter and see if it is working or not. So as I said, I reduced the diameter of these carbon tubes a little bit using the sandpaper, and now we will try to insert these bushings. There is a little difficulty inserting into this at the start, but once it get inserted, you can see that how smoothly it is running over the tubes. So we required this 30 centimeter of span length to be 10 and not the end. That's why I have not taken care of this end part, because this is not required. This will go into the clamp, and the bushing will slide onto this span length only, and you can see that now it is running smoothly without any sticking. Similarly, and on the other tube also, you can see how quickly this is running. So now we will mount this onto the X gantry, these rails and these rod, and we will see how it performs. Because when we will screw these mountings onto the X gantry and then we will insert, there will be little difficulty. These rails will not move as it is moving right now, because there will be slight deviation because of screwing here. So we will see how it performs. So I have M3 screws and M3 nuts over here. So now we will connect this using M3 nuts and bolts. Here the extruder will come on this surface. That's why this provision is given over here to go in. Head will go inside and sits there, and there will not be any protrusion of these heads outside, because this surface we required as plain for mounting the extruder. So we will tighten this little bit. And now we'll try to insert the rods inside this. So right now there is no clamps attached at the end, that's why these are not staying as a straight, but you can see the rods are coming very smoothly. So we will attach the clamps at the end and see how it performs. So these are the XY joiners which will connect the X and Y axis together. The two X-axis will go inside this. These are the 10 mm dia hole is provided over, and we will clamp at this side. And these are the clamps for these XY joiners. So onto this LM8L UU bearing will sit, and 8 mm dia our Y axis will go inside this. That's why this is called as a XY joiner. And you can see there are the slots provided over here, as you can see. This is for the belt which will coming from this and will connect to this X gantry. And similar provision is provided on the left side XY joiner. So there will be two XY joiner at the two ends. So now quickly we will connect and see. So now it's a complete setup for our X-axis, and you can see how smoothly, still it is smoothly running over the our X-axis. There is little stucking over here, you can see little binding over here, but over the period this won't be any problem, will get smoothly. And also we require the span length from this to this end, up to this only, from here to here, so our gantry will not move at the extreme ends. I am very happy with this performance. There is no any binding, you can see how smoothly it is running. With this we will conclude this video, and in next we will install our Y-axis to the frame. So stay connected with me. Thank you.